This is the lesson for Chapter 1, Lesson 6 for Math 8. We are going to skip the top part. We are on page 51, which is the first page of Lesson 6, Scientific Notation. So this says a single-sided, single-layer DVD has a storage capacity of 4.7 gigabytes. 1 gigabyte is equal to 10 to the 9th bytes. Write a multiplication expression that represents how many bytes can be stored on the DVD. So this goes like this. It'd be 4.7 and then times by the number of gigabytes. So 1 gigabyte is 10 to the 9th. So times by 10 to the 9th. So to figure out how big that is, they have this table here. So we're going to look at this table and go through each of these things here. So 4.7 times 10 to the 1. Well, let's see, 10 to the 1 is just the same thing as 10. And 4.7 times by 10 means I would just move this decimal over one time. So it's just 47. When I have 4.7 times 10 to the 10 times 10 squared, I would move it over 2 times. And what do I put in place of that, like where this should be? What would I put there, Abby? A 0. So this is going to be 470. So this one, 10 to the 3rd, how many times? Raise your hand. How many times am I going to move the decimal? How many times? 3 times. So I'm going to move it over 1, 2, 3. How many zeros am I going to add into there? Very good. You're going to add in 2 zeros, so 4, 7, 0, 0, and then I need to put a comma right there. Yes?
Do we have to put a comma?
Yeah. How many times do I move the decimal here on this one? How many times, Lena?
4.
4. And then Sam, how many zeros would I add in? So right here, I moved the decimal 3 times and I added 2 zeros. So this one, I'm moving the decimal 4 times. How many zeros do I add on this one?
3.
3, good. So 4, 7 with 3 zeros, and then I can put the comma after the 7. Missing something here. 10, 100, 1,000. So what goes right here? Okay, yeah, 10,000. Okay. On the other hand, they have these negative exponents. Remember how we talked about flipping them?
Mm-hmm.
So we're going to be dealing with these negative exponents again. And so this one, this would mean that we move the decimal the other direction 1 place. So then it's going to be 0.47. This one, how many places are we going to move this decimal? 2 decimals. So this is another question that people have asked. Do you have to put the 0 before the decimal? Technically, no. But when you're writing things down, I can tell you from experience grading homework when people, or tests when people did not put the 0 before, lots of mistakes are made. So we're going to put the 0 before, and then what would go right here?
0.
Another 0, and then 4, 7. Here's another way of looking at it. So notice I had -1. That means that I had 1 0 before the decimal. Before the 4 and the 7. This one I had 2 zeros before the 4 and the 7. So if this is 10 to the -3, how many zeros before the 4 and the 7 am I going to have? 3. But then the decimal needs to go after that first one. So I would move this over 3, and then I'd have 2 zeros right there. And then this one, how many times would I move the decimal on this one? I like how you're just showing me in the air. Very good. 4 times 1, 2, 3, 4. And I had to go sideways so I wouldn't write over that. So I'm going to have a 0, and then 1, 2, 3 zeros, and then 4, 7. And the last part of this, if this is 1 over 10, 1 over 1,000, 1 over 100, 1 over 1,000, this is 1 over what? 10,000. Okay, what do you notice about this table and the similarities between the left side and the right side? What similarities do you notice? What do you notice?
Well, you're just moving the amount of places of how many zeros.
Yeah, so you're moving the decimal and then filling in with zeros, right? On both sides, moving the decimal and filling in with zeros. That's good. What else do you notice? Yeah.
The right side is going into negative.
So the right side has negative exponents, and then these numbers go really small. And then what can you say about the difference between these two parts right here that I'm pointing to? What do you notice, Sarah?
One on the right is fractions.
Yeah, so this is just this number over 1, right? So this is 10, 1 over 10. 100, 1 over 100. Jordan, what else do you notice?
I noticed that if it's positive, it goes to the right, and if it's negative, it goes to the left.
In fact, that's what we are going to write in the margin. So this form, okay, so positive exponents. Everybody's writing this down. Positive exponents move the decimal to the right. So positive exponents move the decimal to the right. So what do you think negative exponents do then? Good. Negative exponents move the decimal to the left. In symbols, this is how I do this. Positive means right. Negative means left. Like the normal number line, correct? Okay, so then 4.7, did you guys get that down? Next part, we're doing number 3. 4.7 is multiplied by a positive power of 10. What relationship exists between the decimal point in the new position and the exponent? So I want everybody to do positive here. A positive power of 10. Where's the new decimal? Is it to the right or to the left? What did we say? So it's moved to the right. And I would write a full complete sentence, for the sake of time, we're going to do this one. What about if it was a negative power of 10? It's moved to the left. When we took that day and we're on the computers and looking at the htwins.net. Do you guys remember looking at htwins.net when we were looking at like the giant earthworm or did you guys look at that stuff? Do you remember looking at that stuff? The giant earthworm or the Minecraft, like Minecraft world or whatever it is. Those were all written in powers of 10. Those all had to do with powers of 10. And all that has to do with scientific notation. With what? Okay, so it's basically when you take a number and write it as a multiplication to the timesing by something to the power of 10. So it looks like this. It'll be like a number times 10 to some power. But then the trick is this number has to be between 1 and 10. In other words, like 4.25 is between 1 and 10. So the decimal has to go after the first digit. I want you guys to put an arrow right there. And I'm going to put decimal after the first digit. That's not 0. So the decimal has to go after the first digit. So on this one, I would also put an arrow right there. I would want it to go after that 4. And then we do just like we did on the other side and count how many times I would have to move the decimal. Right now on this 425 million, where is the decimal right here on this part? Where's the decimal that we don't write? Where is it? at the very end at the 0. So then we would have to move this decimal over 1, 2, 3, 4, 5, 6, and we want to go to where that arrow's pointing, 7, 8. So that's why it becomes 4.25 times 10 to the 8th. Is this making sense?
Yeah.
So we're going to have to go from back and forth. This form right here is called the standard form. What is this part called right here? Standard. And then this one is the scientific notation, which we can abbreviate SCI, S-C-I, and then not. Scientific notation. SCI-not. Do you guys recognize doing this in science? Yeah, good. So then our goal right now is just to go from back and forth. So this is 5.34 times 10 to the 4th. So this says that we're going to move the decimal. So I want you guys to circle the 4. And since it's positive, we're going to move it to the right. So I want you guys to circle 4 and put right. And on number 2, I want you to circle the negative 3. And since it was negative, which way do we go? Left. And so then we'd actually take that decimal and move it that many to the right, or in this case, that many to the left. So 4 to the right. So 1, 2, 3, 4. We have to fill those in with 2 zeros, so it's 53,400. Make sense? And then this was negative 3 to the left, so we'd move it this way. 1, 2, 3. The decimal would go right there, filling in the blank spots with the zeros. So it goes like that. So 3, yeah, like that. 0.00327. So I want you guys to do these problems, but make sure that you give yourself a hint. And maybe you just want to like circle the 5 and then put an R to remind you that you go to the right. Or if it's negative, put an L to remind you that you go to the left. I want you to do these 3 problems right here. And I'm going to come around and check. So you can put your answers off to the side or right underneath. You choose. You're doing a great job.